Hey there, welcome to Solve My Math Homework. So today a subscriber sent in a bunch of linear equations, so we're going to try and get through as many of them as possible. So before we begin, let's talk about the basics of solving an equation. Let's consider this really easy equation, 6 equals 6. Nobody would argue that 6 is in fact equal to 6, and that's why we're going to use it. So if we add 2 to both sides of this equation, would we still have a true statement? And in fact, we would. We would have 8 equals 8. So it still works out. That just shows us that if we have an equation, we can add the same value to both sides and maintain the equality that was there. So when we solve equations, a lot of times we have to add the same value to both sides, but you have to do the same value to both sides. So again, let's look at 6 equals 6, and this time subtract 2 from both sides. And of course, you already know, if we subtract 2, we're going to get 4 equals 4. It is still an equality statement, or it's still a true statement, so we can subtract the same value from both sides of an equation as well. So those are two of the big properties your teacher will probably talk about when solving. The addition property of equality and the subtraction property of equality, they really just mean you can add the same value to both sides of an equation and you can subtract the same value as long as you do the same value and you subtract it from both sides of the equal sign. So in your book, it looks like this. If A equals B, then A plus C equals B plus C. This just means if you start out with something that's true and you add the same thing to both sides, you still have a true statement. Same thing with the symbolism that will be for the subtraction property. Just says if something is true and you subtract the same value from both sides, it's still going to be true. So these properties will be talked about, but really it just says you can add or subtract the same value to both sides. And guess what? They have properties for multiplication and division as well. So let's look at those. If we have 6 equals 6, because we're used to working with it, and we multiply the same value to both sides, negative 2, negative 2. Negative 2 times 6 equals negative 2 times 6. It seems silly to say that we have to prove this, but yeah, negative 12 is equal to negative 12, so we can multiply to both sides of the equation as long as we multiply the same value, and we will maintain equality, so it will still be a true statement. And the same goes for dividing by both sides. So let's start with 6 equals 6. Let's divide both sides by negative 2. If we divide both sides by negative 2, we get negative 3 equals negative 3. We still have a true statement. These are two more properties that we use when we solve equations. The multiplication property of equality simply says you can multiply the same value. As long as you multiply the same value and you multiply it to both sides of that equal sign, then you will maintain a true statement. But the symbolism in your textbook looks like this and it's not friendly at all. And then they have this little where C can't equal 0. Well, sure, because anything times 0 is 0. So you'd have 0 equals 0. You'd still technically have a true statement, but you wipe out everything that's there. All right, division property of equality looks like this in your textbook. If you start out with a true statement and you divide both sides by the same value, you still have a true statement. So if you need to, you could divide both sides of an equation by some value. This time, C really can't equal 0, because remember, we cannot divide by 0. If you have $10, you cannot divide that equally among 0 friends. Just can't be done. Okay, so let's move on. So these properties, remember, they look scary. They just say that you could add, subtract, multiply, or divide as long as you do it to both sides, as long as you use the same value. All right, something else that we need to understand when we're solving equations is inverse operations. It's really just to get the variable alone, but your teacher is probably saying isolate the variable. So think about what isolation means. In isolation, you are alone. We are trying to get the variable alone. And we will get the variable alone on one side of the equal sign. That's what it means. It's either all by itself on the left side of the equal sign or all by itself on the right side. And when we do that, we use inverse operations. Another scary term, but it just means that they're the opposite operations. They're operations that undo each other. And again, the goal is to get that variable alone on one side of the equation. So let's start looking at problems. Let's look at C minus 3 equals 19. So we have an equation, we have an equal sign, we have a variable that we want to get alone. It is not currently alone on the left side of the equation, right? So how is that number, how is -3 attached to the variable, or how is 3 attached to the variable? It is, or is the variable already isolated? Maybe this is done for us. Is C all alone on the left side of the equation? Well, I kind of tipped the hat and said that it wasn't, so we know that it is not. So no, C is not alone on the left side of the equation. We have a 3 on the same side with it. So we want to know, how is that 3 attached? What operation is holding the 3 with the C? Well, if we read it, C minus 3 will give us the operation. C minus 3 means subtraction is holding the 3 with the C. Woof, should have picked a different variable, but I didn't pick this problem. It was sent to me. All right, so the opposite of subtraction is addition. If you want to get rid of a -3, you have to add 3. Think about this. If you have -$3 in your bank account and you want to get rid of that -3 balance, you have to add 3 to bring you all the way up to 0. So the opposite of subtracting 3 is adding 3. And that's what we have to do to both sides. We add 3 to both sides. So what happens here, -3 plus 3, those are opposites. So we get C plus 0. We have nothing over here now. So C will be alone. So we get C equals 22. Right? 19, 20, 21, 22. Make sure we could still add at this hour at night. All right, let's look at some more. So here we have 3 more equations. Let's work one by one. Let's start over here. So we have y plus 6 equals 2. Again, we have to ask ourselves, is the variable alone on the left side of the equation? And it isn't. It has a 6 on the same side of the equal sign, right? The equal sign is the divider. This is what makes one side of the equation versus the other. So the 6 is with the variable. How is the 6 attached to the y? Well, it is attached with addition. And what is the opposite of addition? The opposite of adding 6 is subtracting 6. So that is what we will do. We will subtract 6 from both sides. We get y equals -4. If your teacher wants you to check it, because I noticed whoever sent me this problem, Kaylee, I think this was you, the teacher said check each equation. So you would simply, instead of y, you would put what you get for y. So -4 plus 6 equals 2, and -4 plus 6 is in fact 2, so it works out. All right, moving on. -5m equals -20. Again, here's our variable. M is on the left side of the equation. It is not alone. There is a -5 with it, preventing us from having a m equals equation, right? That's why we want this variable alone. We don't care what -5m equals. We care what m equals. So how is -5 attached to m? It is attached with multiplication. And what operation undoes multiplication? What's the opposite of multiplication? The opposite of multiplication is division. Therefore, the opposite of multiplying by -5 is dividing by -5. So we're going to divide both sides by -5. So these will just cancel, right? -5 divided by -5 is 1. And we will get m equals 4. How did I get a positive? Because remember, a -20 divided by -5 is +4. Every time you have a negative divided by a negative, you get a positive. Also, negative times a negative, also positive. All right, last one. Well, last one for this set. So we have x divided by 2 equals 3. If you read this equation, you don't say x over 2. If you realize that, oh, a fraction bar is really just a division symbol, right? X divided by 2. That will tell you that A, x is not alone on the left side of the equation, and that it's attached to 2 by division. So when we say, oh, I forgot to do the check for that one. -5 times 4 is, in fact, -20. All right, now for real, moving on. How is this 2 attached to this variable? Well, if we read it, x divided by 2 equals 3, we hear ourselves say divided by 2, so we know that it is attached to the x by division. The opposite of dividing by 2, opposite of division, is multiplication. So we are going to multiply both sides by 2. Now, when I do this, I put 2 over 1. You don't really have to. Everybody knows that you could put a whole number over 1. It's the same as just saying 2. But I do that so that you don't think the 2 is in the denominator. You got to be really careful because we want to divide out or cancel out these 2's. So what's going to happen is we will be left with just x over 1 on the left side, which is simply x. And on the right side, we will get 3 times 2. So we get x equals 6. And we're going to check this one. 6 divided by 2, right? We just replace the x with what we got. 6 divided by 2 is in fact 3, so it checks. All right, what if you have more than one step? So you have more than 2 or more than 1 for right now number on the same side of the equation as the variable. So let's look at equation like 3z minus 6 equals 9. All right, I want you to think of solving these two-step, or sometimes they're called multi-step equations. Think of the variable, the thing that you want to get alone, as a gift, a present. The constant, which is the number by itself, including the sign, right? So the negative 6, it's furthest from the variable. I want you to think of that as the ribbon. And the coefficient, so the number that is right next to, either multiplied to or divided by the variable, you want to think of that as the wrapping paper. And so we first have to take off the ribbon and then get to the wrapping paper. So you work from the furthest thing from the gift on the inside of the box, removing the ribbon, and then the wrapping paper. So could you do it any order you want it? Yes, but it gets a little dicey. If you chose to divide by 3 first, you would have to divide everything. But because we can only add and subtract like terms, always, always, always get rid of whatever's added or subtracted first. All right, so let's see this one in action. So we have 3z minus 6 equals 9. We want to get rid of everything furthest from the variable first. So we will get rid of everything, but we're going to start with whatever is being added or subtracted. So what is that going to entail? That's going to entail the negative 6. So the opposite of negative 6, or the opposite of subtracting 6, is adding 6. So we will add 6 to both sides. Now, you don't have to add it to 3z. In fact, you can't. You can only add like terms. You can't add a z term and a 6. That's why adding or subtracting is the best to do first, because I only have to do it to the numbers that are by themselves. So then we get 3z equals 15, right? 9 plus 6 is 15. So now we're back to a one-step equation, which we already solved. So is my variable alone? Is z all by itself on the left side? No, there's a 3 with it. So how is it attached? Well, the z and the 3 are multiplied together. The opposite of multiplying by 3 is dividing by 3. So we'll divide both sides by 3, and we'll cancel out, right? 3 divided by 3 is 1. We just get left with a z. So we get z equals 5. Whoops, and I went to x. I'm really bad with other variables. I just want everything to always be x. So z equals 5. And we'll go ahead and check this. 3 times 5 minus 6, does it equal 9? All right, order of operations. You have to multiply first. So I'm going to get 15 minus 6 equals 9. 9 does, in fact, equal 9. All right, let's move on to another one. Oh, looks like I did not animate that. Sorry about that. Let's look at this equation and pretend r equals 12 is not down there. So again, we are going to work from the furthest from the variable, r divided by 2 minus 4. Minus 4 is furthest. It's also what's being subtracted. We always want to tackle whatever's being added or subtracted first. So we are going to get rid of the negative 4 by using the opposite of subtracting 4, which is adding 4. So we'll go ahead and add 4. Now I wrote it a little different way because some teachers write it like this. I don't love it. I really like writing it underneath. But in case you ever see it like this, r divided by 2 minus 4 plus 4. Well, you know, if you have minus 4 plus 4, that's going to be 0. It just cancels out. Equals 2 plus 4. Some people like to write it horizontally. That's fine. I think it's a little ugly, but, you know, to each his own. So when we simplify this, remember, negative 4 plus 4 is 0. So all we're left with here is r divided by 2, and 2 plus 4 is 6. And again, we are back down to a one-step equation, which we already know how to solve. So what is the opposite of dividing by 2? Of course, multiplying both sides by 2. So we multiply both sides by 2. Remember, I put 2 over 1 so that you could see 2 is clearly in the numerator, and it will cancel with the 2 in the denominator. So cancel those out, and you're left with technically r over 1 over here, but we don't care about r over 1 because r over 1 is simply r. So we get r over 1 equals 6 times 2, r equals 12. We kind of knew that already because I forgot to animate my last step. All right, and if you wanted to check this, you absolutely could. 12 divided by 2 is 6. 6 minus 4 is 2. So if you have to show your check, go ahead and show your check. All right, last one, I think for real, the last one. And again, we have a little answer already here. So this one's a little weird because we have the constant before the variable term, right, or the variable expression, right? We have -2 plus w over 7 equals -2. Well, we still have to get rid of whatever is being added or subtracted first. It's still technically what's furthest from the w, so we are going to get rid of -2 by using the inverse operation of subtracting 2. Technically, this is a -2, but the opposite of a -2 is +2. So we still have to add 2 to both sides, right? This is what we're getting rid of. We add 2 to both sides. Once we do that, be very careful. You get w over 7 equals, now we have -2 plus 2 on both sides. So we get w over 7 equals 0. A lot of times when kids get equals 0, they think they made a mistake. That's perfectly fine. You can multiply 7 to 0. You could add to 0, multiply to 0. You could even divide a number, right? You can divide 0 by a number. You just can't divide by 0. So don't let that freak you out. What is the opposite of dividing by 7? Remember, we're going back to getting w alone. We're focused on what's with w. It's 7. How is it attached? Divided. So what's the opposite of divide by 7? Multiply by 7. Multiply both sides. We get, whoops, I'll go back. W equals 0. So don't let this 0 freak you out. Don't let the fact that the number comes first freak you out. It's all step by step. You take your steps, you take care of what's furthest from the variable, then what's closest to, so multiplied or divided, and you will get your answer. All right? If you want more help, you know where to find me. Check me out on YouTube, check my Teachers Pay Teachers store, and send me those questions via email. Have a good one.